Hello everyone, welcome back to our next lecture. We are looking at different blockchain platforms. Specifically, last lecture we looked at Ethereum. Now we'll go into some of the Ethereum developer tools and also a permissioned version of Ethereum, Quorum specifically, in this lecture. So Ethereum has over the last maybe 2-3 years, it's really developed in terms of the ecosystem itself. There are plenty of developer tools available. We're just going to talk about maybe a few of them. There are a lot more that are available. I'll have a pointer towards the end of the lecture in our fun reading section on some of the large number of tools that have come up to help developers code on Ethereum. So Truffle is really a development environment, and it's become popular over a period of time. It's built by consensus, and it helps give you a scaffolding of project structure. So you can have contracts, scripts, tests all as a project almost. Then you can have, it has support for built-in smart contract compilation, linking and deployment. You can manage the binaries for your smart contract. It gives you automatic test framework in JavaScript. It gives you a configurable build and test pipeline. It gives you a scriptable deployment framework, and it also gives you the ability to manage your network, deploy into many public and private networks. So it gives you a host of capabilities all around managing your smart contracts, your development, providing an environment for that, giving you the build and test pipelines needed for you to deploy into different networks. And the deployment could go into, for instance, deployment can connect to Go Ethereum client, which is Geth. It's a very popular vanilla Ethereum client. Or it could also connect to other Ethereum variants, such as Quorum, right? TestRPC is a Node.js based Ethereum client for testing and development. It basically simulates a full client behavior as if you were running on the actual public Ethereum network. It actually simulates that behavior, and it helps really improve the speed of testing and development and testing, because you have a single node almost with yourself for development and testing. But it has some limitations. It can only create one transaction per block, so you can't have the full, let's say, full-blown proof-of-work style, multiple transactions created in a block and people are actually mining. All that is not there. This is just the smart contract execution in an EVM box, right? And it serves as a good substitute for Geth or other Ethereum clients during development phase. But it doesn't have any enterprise Ethereum-related capabilities. So Web3j is again a developer framework, and it gives you a complete implementation of Ethereum's JSON RPC client, but it provides this over HTTP and inter-process communication. It has a reactive functional API if you're familiar with reactive. And a cool thing it can do is it can auto-generate Java smart contract wrappers for your create, deploy transactions to call your smart contracts on blockchain. So it gives you the Java application wrappers to invoke your create, deploy transactions on your smart contracts. It's also Android compatible, and it also again supports Quorum. Right? So the Enterprise Ethereum Alliance I mentioned last lecture was formed in March of 2017. The main objective was that there was a group of entities that realized that Ethereum, while it had cool properties, it had a public network and there was a Ether inherent cryptocurrency, it was really not well suited for enterprise applications, in terms of scale, in terms of security and privacy, in terms of throughput, in terms of pluggability, in terms of what different enterprise applications need. There were a lot of shortcomings with the public Ethereum itself. So they wanted to use some of the main constructs from Ethereum, but they wanted to change it in certain ways, actually fork Ethereum, but then modify it for specifically use in enterprise applications. But they wanted to do this in such a way that they can still leverage a lot of the innovation capabilities. For instance, they retained the EVM itself. That was the intent. So all the contracts that were developed for the public Ethereum could also run on the private networks. And you can also leverage many of the developer tools and the ecosystem, the developer community that was creating all of these tools. Those can also be used with your enterprise variants, right? So what are some of the main critical properties they were looking for? They were looking for security and data privacy. We've looked at how Hyperledger Fabric provides many of these capabilities, but they're trying to bring these capabilities into an enterprise version of Ethereum. They want to bring in permissioning. So the public Ethereum is permissionless, which means that anybody, absolutely anybody, can come and join the network, can see the transactions happening. But in enterprise applications, we want it to be restricted to an authorized set of permissioned entities, only those that are performing or part of a transaction. So permissioning is being brought in. They also want to improve throughput. So for instance, one of the things they've done is they've gotten rid of proof of work. They're leveraging other notions of consensus. We'll talk about it when we talk about Quorum. And also trying to bring in a pluggable architecture, right? So I want to be able to plug in different consensus algorithms. I want to be able to plug in different databases. There are different notions that are, different pluggability notions that are being brought in, right? So they're really trying to modify Ethereum in some way, the public Ethereum, for enterprise requirements such as security, privacy, and scale. And as you can see, there are many well-known large corporations, both technology companies as well as financial companies, that are coming together in this Ethereum alliance. As of today, at least, I have not seen an actual code base put out by Ethereum Alliance. They're trying to put out a policy statement or a statement of purpose in some sense of what are some of the things that they want to do, and Quorum appears to be the main platform that seems to be adhering to these specifications, and there's a community building around Quorum. So Quorum itself is coming to Quorum as a blockchain platform. It's a variant of Ethereum. It's a permissioned implementation that is geared towards transaction and contract privacy, right? So the primary features of Quorum, it's an extension of the public Ethereum. It actually leverages the Ethereum virtual machine as is, so you can code in Solidity or some of the other languages that's available. The same bytecode is maintained. It gives you notions of transaction and contract privacy. It has a pluggable consensus mechanism involved, so they've gotten rid of proof of work completely. They've brought in a voting-based consensus algorithm, and they also have support for raft consensus. And they've brought in permissions management, so all the peers and users of Quorum will be permissioned, so they'll have an identity on the blockchain. Finally, they're also looking for higher throughput of the order of about 300 transactions a second. And this is the transaction submission rate, right? This is really a fork of the Go Ethereum client, so they want to be compatible with that going forward, so that as the Geth client goes through versions, new capabilities are added. We talked about some of the capabilities with secure messaging, with sharding, and so on. As they get added to Geth, Quorum wants to be able to leverage that, so they are keeping it as a fork, but they're making sure at least portions of the code are not too different from what they are currently. They're not making too many changes. They're only changing the consensus mechanism, and there are a few other changes. We'll talk about those. Let's look at the Quorum architecture itself. So there is a Quorum node, which is the Goeth client. So this is a slightly modified version of the Goeth client, but they're trying to make sure this is not looking too different, so that future innovations into the Geth client can be brought in quickly. And they have a notion of constellation, which is really a general purpose peer-to-peer encrypted message exchange system. So this allows peers to exchange messages in a privacy preserving manner, and this constellation is also responsible for transaction execution. And the different Quorum nodes adopt a notion of consensus, and the consensus itself, as I said, is pluggable. There's Quorum chain consensus, we'll talk about that, and there's also raft consensus that's supported. And there is a peer-to-peer layer that supports connection between these peers. for exchange of messages. So that's through constellation. And there's a state Patricia tree that's split into two, right? So specifically, they support both public state as well as private state. We'll talk about that again in the next slide on how privacy of contract and transaction information is supported in Quorum. This transaction creation has been modified to allow only the hash or maybe even the encrypted hash of data to be recorded in the transaction, and the private information is in fact kept private. And the other thing that they have gotten rid of is, for instance, there is no public, there's no cryptocurrency as such in Quorum, so there's no notion of ether, but they have, so there's no pricing for the gas. So we talked about how gas is a way that acts as a fuel for transaction execution. So in Quorum, there is no pricing involved, but gas itself remains, right? So they have kept gas itself, so that not to make too many code changes. And the transaction manager is responsible for transaction privacy. Again, I'll talk about that when we talk about the public state and the private state. And the transaction manager doesn't hold any secret information. All of the cryptographic work is separated out into an enclave. So this enclave, for instance, can be run inside an Intel SGX box. So that ensures that the key remains private, and encryption, decryption all happens within this secure enclave. Okay, so let's look at how transaction processing itself works. So the picture on the right gives you the full flow of all the interactions that happen between peers. But let me just give you a high-level overview, right? It might take a little longer for you to understand all of these interactions. For that, I would encourage you to read the Quorum documentation, have a pointer at the end of the lecture. But let me give you the gist of it, right? How are they achieving transaction data privacy? Quorum supports two kinds of transactions, public transactions and private transactions. The two cannot be mixed, right? For instance, I can't have a transaction that handles both public state as well as private state. Now, the public transactions are similar to Ethereum, right? When a transaction is public, each participant will execute the same contract on the same data, and all the data, modified data, is going to get recorded in the state database and it will be recorded on the blockchain. So the state data, the public state data will be in the transaction and is recorded on the blockchain. So that's public for everyone to view. Everyone in the network. So Quorum does not have the notion of channels similar to Fabric. So in the network, everyone sees all the transactions. The only thing you can keep private is the data itself. There's some data that you can hold private, but the transactions themselves, there's no notion. So all the network participants will see the public transactions. Now, separately from the public transactions, you can also have private transactions that are only visible to a subset of the participants in the network, right? So the other nodes in the network will see that some transaction exists, but they won't see the details of it, right? So it will have information about, it will basically have a private for field, and it will mention the entities that the transaction is private for. So one notion of privacy you do not get with Quorum is that private for field itself is public. So people will know, so let's say there are 15 participants in a network. There are 3 participants who are trying to do a private transaction. The entire network of 15 participants will know that these 3 entities are doing something privately, and they don't want to disclose that to the rest of the network. What they are doing will be kept private, but the fact that they are doing something privately is known to everyone. So that cannot be obfuscated. Fabric, for instance, it's possible to hide that also, but with Quorum, it's not possible to hide that. So how does this private transactions work? So in the private transactions, as I mentioned, there's a private for field that mentions a list of entities to which this transaction is private. So only those entities will get the transaction data. And the Quorum node propagates the transaction to the rest of the network. So what it does, it replaces the payload, which is intended to be private in this transaction. It replaces it with just a hash. And the encrypted payload is sent to the constellation. So the constellation in each node So if you are an authorized entity of this private transaction, so if you are part of the private for field, then within your constellation you'll be able to decrypt it because you have the key. You'll be able to decrypt it and execute the transaction and see the decrypted content. But all the others will only receive a hash. In some sense, this is similar to SideDB in Fabric, because you can now, in Fabric, you can have private collections and you can have a subset of entities in a channel part of a collection. This is similar to that, except that SideDB in Fabric allows you to handle data pertaining to multiple. So one transaction can actually have data pertaining to multiple collections, each collection having a different set of participants, and it can also have public data within it. Whereas here, a transaction has to be either public or private, and if it's private, all the data within that transaction is private for that set of entities. So you can't have multiple collections, one transaction operating on multiple collections. So that's really the difference between Quorum, the privacy notion in Quorum, and the privacy notion in Fabric. But in some sense, because there is a restricted functionality, you could also imagine that maybe it might be easier to achieve this privacy. You don't have to work with the many policies that are there in Fabric. But I've not personally tried out Quorum for myself, so I'm probably not a good judge of that. So we looked at the transaction processing in Quorum, how public and private transactions are supported. So now let's look at consensus. How does consensus work? So like I mentioned, they've removed the proof of work consensus in Ethereum, and they've replaced it with a pluggable notion of consensus. So today there are some implementations of this consensus that's available. One of them is Quorum Chain. So it's their own consensus algorithm. So it works based on voting. So each peer can have one or more roles. It can be a maker, which is the peer is responsible for creating the block. There could be a voter, which is responsible for voting on whether a block is valid or not. And there could be observers who are just verifying or just validating whether a block is valid. So the most recent block with the most votes is considered the head of the chain. Right? So there could be forks, of course, but as people vote on it, the head will get determined, and hopefully a single chain of transactions will emerge. So there is inherently, though, this whole voting mechanism is also implemented as a smart contract. It's called block voting, and that smart contract is loaded in a pre-specified address, and that's part of the Genesis block. So it's already, the Genesis block itself comes with a particular particular smart contract that's loaded, and that smart contract is responsible for consensus. So that's a quick overview of Quorum and some of the developer tools available with Ethereum, and most of those developer tools also work with Quorum. So for a good list of the developer tools for Ethereum, you can look up the Ethereum GitHub repo itself. There's a lot of these developer tools. You can check those out. The Quorum white paper is an interesting read. It's a very high-level overview. Again, you can check that out. The overview documentation has a good bit of information. So I would encourage you to read that as well. So I briefly mentioned Raft consensus. So Raft is really a fairly old protocol that was built as an alternative to Paxos. So if you've seen Paxos is a crash fault tolerant algorithm, consensus algorithm, and people believe that Paxos is very hard to understand. So Raft actually was devised as an alternative to Paxos so that people can actually understand how this consensus algorithm works. So you can check out the Raft paper itself. So it's a good read on how that consensus works. Okay, so that brings us to the end of the two-part series on Ethereum and Quorum. So in the next couple of lectures, we look at Corda and some of the interesting properties and capabilities Corda provides. Thank you. See you soon in the next lecture.